Hello everyone. In this video, we learn complementation of non-deterministic finite automata. Complementation of NDFA. So we already learned complementation of DFA second. Now we will learn complementation of NDFA. So let's understand this concept with the help of example. Let's say I have a language which starts with A, assuming that our input alphabet is A, B. So in this language, every string starts with A. So what are the possible strings? Possible string is A, AB, A, AB, ABA, AB, AA, and so on. Means this language is infinite. If you draw the transition diagram for this language, then you will get the structure like this. Small a, capital A is the initial state. Then on seeing small a, it will go to the state capital B, which is final state. And final state will accept any number of A's or B's. The main concern here is we always start the language with A. Okay. Now, so this particular NDFA will contain all the tuples as per the definitions. What are the tuples? The tuples are Q, sigma, delta, Q0, and capital F. Okay. Now, if you complement this language, complementation means all the final state will become non-final state and non-final state become final state. So complementation will give you all the tuples as it is, only one tuple which is capital F. Capital F will be replaced by Q minus F. So if I draw the transition diagram for this, if I draw the complementation of this particular language, then I will get A is become final state, okay, and this is the transition move for a small a input, and it will go to the non-final state capital B, and here I will accept any number of A's or any number of B's. Okay. So in this particular transition diagram, if you observe what the resultant language is, let's call this language as L1 and this language as L2. You will find that this language contains only one symbol, which is epsilon, because on final state capital A, it will not accept any string. Okay, so if any language does not accept any string, that means epsilon is present in this language. Epsilon is present in those languages. But we do not want after complementation. We do not want this language. We want language which will not start with A. It may be start with B. It may be start with or any other symbol. So the concept here is, if you complement the NFA, then the language, then the resultant language may or may not be complemented. Okay, so complementation of NFA will not give you the complemented language. And complemented language. Yes, it may or may not. Okay, may or may not. But in case of DFA, if you complement the language, you will always get the complemented. If you complement the particular DFA, you will always get the complemented language. For example, let's say in this language, if you complement the language which starts with A, then you will get the complemented language which does not start with A. It may be it will start with B, or it will accept epsilon symbol. Okay, so complementation of DFA and complementation of NFA. NFA means NDFA. Complementation of DFA and complementation of NFA always different. Okay, complementation of DFA will get you to the desired result, but complementation of NDFA will not get you to the desired result. Okay, so this is all about the complementation of NDFA. In the next video, we will see a new concept in theory of automata.